Welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Digital Agriculture Team and hosted by students at the University of Nebraska.
The FarmBits podcast comes to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agriculture industry, we hope that you step away from each episode with new practical knowledge of digital agriculture technology.
Hello, FarmBits followers, and welcome to another episode of the FarmBits podcast. I'm Taylor Cross.
And I'm Kelsey Swantek, and we're glad to have you with us as we continue our discussion about remote sensing and precision irrigation technologies.
This is part one of a two-part episode with prior host Jackson Stansell, who is now the CEO and founder of Sentinel Fertigation.
Jackson shares his experiences with fertigation scheduling to increase nitrogen use efficiency and productivity in irrigated corn operations across Nebraska, Kansas, and Colorado.
As the CEO of a startup, Jackson has a great perspective on new digital and precision technologies in agriculture.
With that in mind, let's jump into part one of this episode with Jackson.
Jackson, could you just go ahead and introduce yourself? Tell us a little about who you are, where you're from, and how you got into the position you are in today.
Yeah, so I'll try to make a long story short. I'm Jackson Stansell. I'm founder and CEO of Sentinel Fertigation, also a part-time PhD student here in the Biological Systems Engineering Department at UNL. My hometown is Dothan, Alabama, which is the self-proclaimed peanut capital of the world. We host the National Peanut Festival there every year in early November, so it's coming up. Unlike Nebraska, where the rotation is soybeans and corn, we're on a peanut and cotton rotation down there. So peanuts are our soybeans and cotton is our corn. I went to Harvard for undergrad and played football up there. Ended up making my way out to Nebraska for grad school to pursue agricultural engineering, where I was on the image-based fertigation scheduling project that ultimately led to where I am today with Sentinel.
Very cool. So Sentinel, you mentioned, is a startup. You're the CEO of it. In terms of its actual core product offering, what is Sentinel Fertigation?
So Sentinel Fertigation is an ag tech company that is leveraging digital technologies to empower precision fertigation management. So what we really do right now is provide the in-time fertigation management system, which is a web-based software platform that embodies image-based fertigation scheduling, right now specifically for irrigated grain corn, as well as other fertigation management tools that are empowered digitally. So some of that is application logging functionality that's built for fertigation. Some of that is prescription technology that's built for fertigation specifically, as well as for ground/mobile machinery. But overall, we're an ag tech software company that is really trying to provide fertigation management solutions.
So in your if I'm correct, in your graduate program is when you kind of made this the fundamental software for that's kind of started Sentinel Fertigation. So was there a defining moment or specific point where you remember that you realized you wanted to turn this research into a commercial company?
You know, I don't know if there was really a defining moment. I think overall, a perspective that I have, especially after going through graduate school, is there's not enough research that goes on at the university. And this is not just true for Nebraska, but I think universities really across the US and probably globally as well. There's not enough research that really makes its way out into the commercial world to be leveraged by folks to actually make an impact at scale. And so that was something that I kind of had an idea of going into graduate school, but I think became more obvious through graduate school. And I was, very fortunate, as you all are well aware, to have been able to leverage the On-Farm Research Network to complete, development and testing of the image-based fertigation scheduling framework. And through that experience, working with growers, you kind of get excited, right, about the opportunity that this technology has to make a positive impact on farmers. And so I would say that experience, not a single defining moment, but the experience of working with farmers throughout that process of research and development was what encouraged me to want to make this a commercial solution to provide something that is actually tangible and usable by those farmers. And then through some other, entrepreneurial support that's available here in Lincoln, specifically for University of Nebraska students and employees, New Tech Ventures, such as their customer discovery program. the ideas and wheels started turning for how this really could look as a commercial solution. So, while it wasn't really a defining moment, I would say that really the entirety of my grad school experience was kind of pushing towards this, wanting to get, image-based fertigation scheduling out as a commercial solution. And really it was backed up and kind of affirmed by our research results that we've gotten through the On-Farm Research Network.
So we're already noticing there is a lot of research that has gone into this when it was research and now that it's a commercial business. That being said, who is this actually accessible to? Who is your target customer? Is this just for researchers? Is this to keep at the university level, or who are you trying to market your product to?
Yeah, so our target customer right now is a current fertigator who has existing investments in precision agriculture generally, or at least a desire to kind of pursue a next level sort of efficiency within their operation. I would say that is kind of like our beachhead target customer. Now, in terms of like the broad customer segment that we're going for, we're really going for farmers of nitrogen intensive crops across the board. And we're starting there. We're starting on that process with fertigation because it is such a complex management scenario where timing is the biggest lever for improving efficiency. And critically, one of the interesting things in precision ag, I think, is the role that agronomists play. So farmers are really our end customers, but we also have kind of an intermediate customer, which is our service provider partners, right? And so these folks are generally agronomically trained individuals that we pair with our farmer customers to make sure that farmers are well supported in using the technology and have some human insights to layer on top of the software. And so that's kind of another customer segment, not quite as much of a customer as it is a partner. But I would say that's another important thing to keep in mind when thinking about our customers.
Yeah, that is really neat. And you mentioned New Tech Ventures just recently, but how else has digital ag played a role in your startup, and how were you able to bring your precision digital ag technologies to New Tech?
Yeah, I mean, digital ag is at the core of everything that we do. I mean, when it comes to software, everything is digital. I would say that the digitization of agriculture in general is empowering a lot of what we are able to do. So if you think about yield maps now being stored digitally, it gives us a better view of crop productivity variability across a field. We now have the ability to capture soil properties digitally, whether that's from a soil sample or from an electrical conductivity map. We have elevation and slope data that we can derive digitally. We have images that are now stored digitally. So comprehensively, we're collecting a ton of data digitally in agriculture. The proliferation of software platforms that help manage this data, from systems like John Deere Ops Center to FieldNet from Lindsay to AgSense. I mean, you name it. I mean, even Ag Leader Advanced, right? You can kind of name a software package, a farm management information system that is helping folks manage this data. And so with our system, we are integrating a lot of this digital data into a system that leverages imagery to determine whether or not additional fertilizer would benefit a field over the course of a growing season, right? And so I would say digital ag is essentially everything that we do, and it also empowers kind of what our core technology is, because we have to be able to bring all this data into one place in a digital format in order to leverage it for successful and reliable recommendations.
So digital ag, obviously super important. How does that fertigation recommendation, how is that digital ag, and how does that software work? What can producers expect from the system?
Yeah, so I may back up, and I don't know if this is going to hit on something that you want to talk about later, but when we were starting this research on how to use images to drive fertigation management decisions throughout the course of the growing season, we started processing all of the as applied data that we received from machines manually, all the image data that we received from our drones manually, and it was a really time intensive process. We realized pretty quickly that that time intensity was not going to allow this methodology to scale up and really apply to a lot of fields. So the only way to really scale it up and not make it manual is to automate that process. And the way to automate that process right now is through software. So for our customers, when they now see In-Time FMS, the web-based software platform that is our core product, when they log in, they see their field dashboard. And from that field dashboard, they can go in and they can see their field status. So whether or not fertigation application is required based on the most recent image that has arrived in the system. They can access analytics. So they can actually pull up the image, view the image overlaid on their field map, alongside a multitude of different layers that are in the system, such as management zones or their application sectors or their indicator blocks, which we can talk about what all those mean. But generally, they're geospatial layers that define different regions of the field that might be of interest to a user. That analytics layer is also available in a complete format so that nothing is really hidden. Like everything is really available and accessible to our users from an analytics standpoint. So they can go as in-depth or as shallow as they really want to be in those analytics. From those analytics and from the recommendation that's provided, our users can opt into the recommendation. So they can either choose to follow the recommendation, whether that's that no additional fertilizer is required or that additional fertilizer should be applied. They can opt into that and then create a prescription for their system to make a fertilizer application at a rate that is either designated by the system or edited to be the one of their own choosing. And then after an application is made, according to one of those recommendations or not, user can go in and log that application to keep track of the nitrogen fertilizer that's been applied over the course of the growing season, so they constantly have a record of that total to keep themselves kind of on track throughout the course of the growing season. So generally, that's what's accessible to our users. There's some setup that goes into it from a configuration standpoint, but once we get into the season, we're trying to make it as simple as possible. Really, for most users, that is just looking at a text and seeing, what is that recommendation for my field, and not even entering the dashboard at all. So.
Yeah, I think that simplicity is key in a lot of operations. And so how do you best demonstrate to your target customers the positive impact potential that this fertigation suggestions and software might have on their own operations?
I would say that there are really three ways. So first, when we go to meet with a new customer, we sit down with our implementation specialist, customer, and ideally that customer's agronomist. Get them all on the same page, and we kind of talk through what their current nitrogen management program is, what are they seeking to solve about that nitrogen management program, and really get an understanding of the system of their operation. What different things could impact nitrogen management across the board. Once we have answered some of those core questions, we have a general idea of how much improvement we think we could make in an operation. Historically, our method has yielded NUE values of somewhere in the 0.6 to 0.7 range. So that's 0.6 to 0.7 pounds per bushel, pounds of nitrogen per bushel of corn grain produced, right? So within those questions that we're asking about a typical nitrogen management program and typical yields, we have an idea for what a typical NUE is for this grower. So we have already a kind of a numerical quantification of how much impact we think we could make on the efficiency in that operation. From that point, we launch into kind of a demonstration of our software, which I think really makes the entire methodology very tangible for a potential customer, for a farmer and their agronomist to be able to see, okay, over the course of a growing season on a field that's not my own, what does it look like to have a series of recommendations based on a series of images that are coming into the system? So that's a really critical step for understanding how it would integrate into the actual operation that we're dealing with. Ideally, a farmer and their agronomist decide, hey, this is something that we want to try out, and we'll take this on one or two pivots. If that's the case, we'll run it for the full year. And I think that gets to pretty much the third and final piece of the puzzle, which is honestly probably the most important in terms of demonstrating the impact that our system can have, which is a performance review of how the system worked over the course of the growing season. So with us, we think it's really important to have a quantification of what the actual performance of the system was. So we want to go in and evaluate our nitrogen use efficiency, our partial profitability, our yields, our total nitrogen applied, our nitrogen savings. We want to do that relative to market prices that are perceived by the farmer customer. So what is that corn price? What is the nitrogen price that they believe they have been subject to in their operations that year? And we want to evaluate how their operation with our system did relative to their, 10-year average in their operation, and whether that's an APH and a typical nitrogen applied, or if they actually have yield maps that have been, produced over the past 10 years. And I think really putting numbers, to the system and comparing that with kind of the standard for that operation is probably the most critical and convincing part of seeing how the system can benefit an operation.
Absolutely. I agree. I think numbers at the end of the day, that's what matters for any farmer, any producer, any business owner. Numbers are what speaks to people.
Yep.
So you mentioned when a producer comes to you and wants to use your system, you kind of sit down with them and show them how your software works. But unfortunately, this is a podcast, so you don't get to show it to us.
No demos today, huh?
Can you walk us through how the End Time software actually works?
I'll do my best.
Complex process.
Yeah. So I covered a lot of the in-season dashboard earlier, which I'll kind of touch on here in a minute. But I also mentioned that there's a configuration element that is required to get fields set up for End Time FMS. The configuration part of the software really starts with field characterization. So fundamentally, we have to have a field boundary for a field in order to get anything started. So that's where everything starts. Once we have that field boundary defined, we really like to quantify the spatial variability that exists in the field as it will impact crop productivity. Ideally, we do that through management zones, and we like to take in really up to 5 different layers for those management zones. We like to have yield history at least 3 years if we can. In a lot of cases, that's not possible, but we like to have it. We like to have soil electrical conductivity maps as well. Again, in a lot of cases, that's not available, but we do like to have it. The 3 layers that actually tend to be more available are elevation, slope, and soil organic matter. All 3 of those we've seen are pretty significant drivers of crop productivity differences and also crop nitrogen response differences. So we really try to gather as much data as possible, especially within those 5 layers about a field, to quantify and map what we believe is going to be the soil spatial variability in that field. Once we've done that, we kind of proceed to collecting operating parameters for the different equipment that might be used to make nitrogen applications for that field, whether that is the mobile applicator that might be used to establish indicator blocks, which I'll talk about in a minute, or whether that is the irrigation system and fertigation pump that's going to be used for making fertilizer applications via fertigation throughout the course of the growing season. So once we have those parameters set, we can kind of delineate irrigated area boundaries and really have all the numbers that we need to be able to drive those prescriptions. Now, I mentioned indicator blocks, and this is probably the most complicated concept. It's really not that complicated of a concept, but for whatever reason, it seems like I struggle to put the right words to it. Really what indicator blocks are is they are nitrogen rate blocks that are put in the field to calibrate images that come into the system. They consist of a high nitrogen rate plot. Enrich plot is what some people might call them. We call them a reference in our system. And they also consist of a low nitrogen rate or an NPOR plot that we call a canary. They're placed directly adjacently to each other in locations that are strategic for that particular field. And essentially what we're trying to do is use a zone sampling sort of approach to sampling images in specific areas of the field based on soil spatial variability. So a lot of people are probably familiar with the enrich strip that is a full field length strip. It's a very similar concept, but the key thing is that we've paired a low nitrogen rate plot with that reference so that we have some predictive outlook, and we also are able to isolate nitrogen from other stress factors. And the way that this looks more tangibly is if you think about a grower that's going to put down a 60-pound nitrogen per acre base rate of 32% UAN at strip till, for example, or maybe they're going to put on 100 pounds of anhydrous. Maybe that's a better example here in Nebraska. Somebody's going to put 100 pounds of anhydrous on up front. To put our indicator blocks in, what we would do for our canary is we would apply those plots at 70 pounds. And for our references, we would apply those at 130 or 160 pounds to provide that high nitrogen reference, right? And so at every one of those plot locations, we would have both of those rates, and we would subsequently use those plots to calibrate every subsequent image to make sure that we're looking at nitrogen stress and not some other stress factor that could be impacting the image on a broader field scale. So we're able to facilitate building of those prescriptions through the software for the indicator block establishment. So that is kind of like the last step in field configuration, is building that prescription. And once the application is made, we like to ingest the as applied data to ensure that the indicator blocks were placed at the right and prescribed spots. If they are, then we kind of launch into the in-season monitoring component of the platform, which I talked about earlier, which is that in-season dashboard where we constantly source imagery from both high resolution and medium resolution sources, both satellite. We bring that into the system. Every time an image arrives in the system, it's analyzed and a recommendation is produced. And if a fertigation application is recommended, then a text is put out to our farmer, customer, end user saying that fertigation is recommended for your field. And that's really how simple things get once they get in season. It's just a constant monitoring and recommendation system, but really getting that field set up is the hard part of the process.
Right. And so you mentioned that you're utilizing satellite imagery in this recommendation part of your platform. What are maybe the positives and negatives associated with that? And why, I guess, are you using satellite imagery compared to UAV imagery?
So I will start with the second part of the question first there. The reason why we're using satellite imagery instead of UAV imagery is because UAV imagery is very challenging to scale. When you think about UAVs right now, with the FAA regulations that we have in place and the expense of drones, it really requires having a pilot pretty much for 1 to 3 drones. In a lot of cases for imaging applications, it's 1 pilot to 1 drone. So you have a lot of labor that goes into getting that pilot around to every different field that needs to be imaged, getting that drone in the air, completing the flight, getting it down, downloading the imagery, getting the imagery to the cloud or to a local computer to be processed, stitch together all of the independent images that have been taken of a single field, bring that together, ensure that the image is of high enough quality, and then push that out to another system to be analyzed for nitrogen recommendations. That is a really long process. The UAV image, like data quality, is actually quite high if UAV images are captured correctly. The issue is the turnaround time. If you're doing this at scale, it really could be, very challenging to get images every week, which is really what we need for this system, and ideally more frequently than every week. And additionally, to ensure that you get high quality images within, 24 to 48 hours after those images were originally taken. So that's ultimately the challenge with UAV data, is that it's very hard to scale and make timely enough for our specific application. Satellite imagery is very different. So for satellites, they're able to capture the entirety of a field with 1 image. So there's no stitching associated. As long as those cameras are calibrated correctly, then they're capturing high quality data. And because there is no stitching associated, they're scalable. They're able to get around to hundreds, thousands of fields. I mean, they're covering, millions of acres, in some cases in a day for 1 satellite. When you're able to get around and have that sort of throughput, it's very easy to get images turned around quickly. So for both of our providers, it's not rare to have turnaround times that are under 24 hours from image capture to delivery to analytics to recommendation generation in our system, which is really what you need to have a timing intensive scheduling platform like what we have. So kind of getting back to issues with satellite imagery, what you run into with satellite imagery, unfortunately, is clouds. That's kind of the major impact. Wind doesn't really impact satellites, right, like it does drones, but clouds can have a major impact in trying to find the right sun angle to capture images. A lot of satellite providers deal with the sun angle because they can kind of anticipate orbits and sun angles to deal with that. But the clouds are something that almost nobody can really get around unless you have some sort of quality control. The way that we're dealing with that on our end is building out some automated QA/QC procedures and the software to check for clouds and images that leverages some of the layers that are provided by these satellite data providers that basically indicate whether or not clouds are in an image and where they might be in an image, and then allowing you to either filter around them or just toss an image that might have a cloud in it. So I would say that remains to be the major issue with satellites. And resolution is kind of another big limitation of satellites. Planet scope is one of the most commonly used sources of satellite data in agriculture. The resolution on that is 3 meters per pixel with their multispectral imagery. It's a good data set, but 3 meters per pixel really limits you to the size of plots that you can look at in a field, which I would say is probably the major challenge. And it's hard to filter out soil pixel background. So those are kind of the 2 major challenges that I see with sort of the planet scope data, and I would say more broadly moderate resolution satellite imagery data. We're also using Airbus's Pleiades Neo constellation for multispectral imagery that comes in at 30 centimeters per pixel pan sharpen resolution, which is starting to approach UAV level resolutions. The challenge with that imagery is how frequently it's able to be captured. So PlanetScope imagery comes in at a near daily frequency. And for our Pleiades Neo constellation data from Airbus, it's coming in at near weekly frequency. And it also has to be tasked, and the AOI constraints, area of interest constraints for those images are larger than what planets are. So really, when it comes to satellite data right now, I think a lot of it is more figuring out what is the right model of distribution and delivery that works for agriculture, more so than it is getting the data that works for making these recommendations in agriculture, if that makes sense.
So I talked about this a few weeks ago with Dr. Shi, and this is really just my own personal interest, but I would say in the last 5 to 8 years or so, there has been a huge push to use drones in ag. That's the best and latest thing. And then very recently, probably the last 2 years or so, that narrative has changed, and now our push is towards satellite imagery. So since you have worked with both, what's kind of, in your opinion, the driving factor behind that change?
I think really a lot of it is scale, truthfully. The folks that I've talked to recently, and I guess this is the perspective that I've adopted as well, is that UAVs are really, really good for very specific applications in agriculture. I think they have significant potential for kind of swarm applications, for spraying, specifically spot spraying. I think they may have some efficacy for cover crop establishment, right? When it comes to imaging, I think they're really good at 3 things. And I think it best leverages their skills if they're used for these 3 things. The first thing is doing stand counts. You're not going to get stand counts from a satellite anytime soon. Eventually we'll probably get there, but anytime soon it's not going to happen. So drones are really good for that because you have a few week window to get that done. And you can get around to all your fields and get it turned around. And it doesn't really require a super timely turnaround time. Basically, scouting for weeds is another thing that can be done with the drone pretty effectively. Needs to be done with the drone because it has to be high enough resolution for AI. And then the third thing is kind of scouting for disease and bugs as you get to insecticide, fungicide time. I think drones are great for those, but until every farmer owns a drone on their own farm and we have, no nighttime flying restrictions and we don't have to have line of sight for a human operator, I don't see drones being scalable enough to do constant monitoring. And a lot of our agricultural applications right now are moving towards this constant monitoring approach, right? Of always having information about a field, constantly updating the model, and being able to provide those timely, actionable recommendations. When it comes down to it, satellites are monitoring the globe every day. And so they're the best source of data that we can possibly use to have the most real-time, actionable information for agricultural fields.
Did you want to go back to question 6? You already answered it. I saw you circled it.
I don't remember circling it.
Oh, okay. All right. Well, all right. So we've talked a lot about Sentinel's functionality within time and their satellite sourcing and so forth. But like everything else, it does have limitations. And so what are those limitations in terms of capital resources? And can the system be used with any brand of pivot and any brand of pump and so forth?
Yeah, these are all really good questions. I'll try not to ramble on for too long. The major limitation, I would say, for our system right now, just from a pure functionality standpoint and application standpoint, is we focus strictly on timing. We don't make variable rate recommendations. We can say whether different parts of your field need fertilizer at different times, and in that way it can be considered a variable rate, but realistically what we're looking at is timing. And so if you're not willing to make multiple fertilizer passes over the course of the growing season to apply nitrogen in conjunction with the recommendations that are made by the system, it's probably not a good fit for that farmer customer right now. There are some things on our long-term development roadmap to solve that and move into variable rate application, but it's that is kind of the core limitation right now, and that's why we are best applied to fertigation at this point in time. The capital resources that are necessary for this system are really not very significant. So the entire end time system was built to integrate into farming operations as they currently exist. So we talked about our indicator block concept earlier. That indicator block concept, because of the way that it's processed on the back end, it doesn't have to be small plots. We can still use field link strips if we really need to. And so for farmers that don't have variable rate application technology on their mobile machinery, and that's how they want to make their base nitrogen application for the year and put these indicator blocks in the field, we can still work with them, right? Because it's built to be able to process on the back end, no matter what the size of these plots are. We don't really have to have a variable rate fertigation pump to do any of this. So because we're timing oriented, we're able to make recommendations for the entire field at one time. We don't have to have variable rates in different parts of the field. We can just say whether or not the field needs fertilizer, right? And so I would say that's another advantage, because we don't require you to go out and get a new chemigation pump. As far as pivots go, it works with really any brand as far as the timing recommendations. And I think ultimately that's, while timing is our biggest limitation, it's also one of our biggest assets, right? Because we're able to go into most different systems and have application without having to require special machinery to make things work. Now, there are some pieces of functionality in our system that are designed for variable rate fertigation pumps, designed to integrate with AgSense, designed to integrate with FieldNet, and some of these other pivot telemetry software that are out there. If you have John Deere Operations Center, we're building an integration to be able to pull data across automatically and integrate that into our system to do site characterization and to post-process as applied data without having to request it from you, right? So there are a lot of there's a lot of functionality that we are building right now and have built already to be able to adapt to this really complex machinery, but none of it is required to get the core value out of the system, which is ultimately increases in nitrogen use efficiency based on applying nitrogen at the optimal time for your crop.
Very cool. So it sounds like it's very usable no matter what your operation, as long as you're set up for fertigation, no matter what your operation has available. What about as far as when it comes to the physical field, the geographies, the crops, the soil types? Is there any limitations when it comes to that sort of thing?
Yeah, and let me back up just one second, because those are good limitations, right? The geography, crop, soil types. The other limitation that I probably failed to mention is we need to be able to get indicator blocks in the field. And so if that's something that a farmer is unwilling to do, right, or there's not really a good base rate application to do it with, where we're going to have to manipulate some other nutrient too much, while also manipulating nitrogen, such as if we're making like an ATS application, right, to establish our indicator blocks, that could be a bad idea. So that's another limitation of the system, is that we do require these indicator blocks, and some folks just aren't comfortable establishing them. And I would say that kind of gets into more of this crops, soil types, geographies situation. So right now, from a geography standpoint, we're only limited by our internal resources at Sentinel Fertigation, right? We don't have a huge team right now. And we're really trying to focus on Nebraska, Colorado, and Kansas, because they are some of the most intensive states in terms of irrigated corn for grain. And from there, we'll expand out geographically as we continue to build a team. In terms of soil types and crops, right now we are limited to irrigated grain corn. We do have some research and development objectives that are designed to push this image-based fertigation scheduling framework outside of irrigated grain corn and into other crops, including potatoes, cotton, sugar beets, and soybeans. So we're really excited about those opportunities. But right now, those technologies are not really available through the platform. It's only corn. In terms of soil types, in research, we applied this technology on a lot of different soil types, everything from a clay loam to a silty clay loam to fine sandy loam to a true silt loam soil to a sandy loam soil. I mean, if there's a soil type out there, while we may not have done a full field of it, we've at least seen it in our research, right? So soil type is probably the least limiting factor. The key thing that we want to make sure that we do in those different soil types is use an establishment method for our indicator blocks that makes sense for that soil type. If nitrogen moves through the soil profile quickly in a kind of a coarser textured soil, we want to make sure we establish those indicator blocks while the crop is growing in the field. If we're in a heavier textured soil, it's more okay to establish those indicator blocks with an upfront application. But ultimately, what that goes back to is just sound nitrogen management practices in the first place. So for soil types, I don't see it being a huge limitation, but that's where we are right now.
Thank you very much to Jackson Stansell for taking the time to join this episode of the FarmBits podcast. It's really exciting and encouraging to see previous grad students of the University of Nebraska-Lincoln taking their graduate research onto the next level in industry through our resources here at the university. I think one of my favorite parts of this episode was hearing how Jackson's company is making the effort to help farmers make more timely nitrogen applications and helping them be more sustainable as well.
Absolutely. It was really cool to see Jackson be so successful as a grad student and turn that information into a commercial company that he can share with the ag industry across Nebraska and eventually the US. It's very cool to see. So I hope you enjoyed this episode, and we look forward to sharing part 2 of this episode in 2 weeks. Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback, so if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can be found in the show notes.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agriculture community in Nebraska and beyond.
The opinions expressed by the host and guest on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska-Lincoln.
We look forward to you joining us next week for another episode of FarmBits.